All right, let's pull back the curtain on the single most important and probably the most invisible piece of software that's running on your device at this very second.
So let me ask you a question. What do you think is the most important program on your computer? Come on, really think about it. Is it your web browser? Maybe that game you can't stop playing? Or the photo editor you use all the time? Well, it's kind of a trick question, because the real answer is a program you probably never even think about, let alone interact with directly.
To get why, you kind of have to see how a computer system is layered. So right at the top, that's you, the user. You're interacting with your application programs. Stuff like Chrome, Photoshop, Spotify, whatever. And then way down at the very bottom, you've got the physical computer hardware. We're talking the processor, the memory chips, the screen, all the nuts and bolts. But hang on, how do your apps actually talk to the hardware? How does a game tell a processor, hey, render these graphics? There's a missing link here, right? A super important go-between that makes everything work. And you guessed it, that's the operating system. Now here's a fantastic way to think about the OS, and it comes straight from our source material. It's basically like a government. Think about it. A government doesn't write your emails for you or edit your photos. But what it does do is provide the essential environment, the roads, the laws, the infrastructure that lets all of that useful work get done in the first place.
So, to put it a bit more formally, an operating system, or OS, is the software that manages all the computer's hardware. It's the critical intermediary between you and the physical machine. It's like the conductor of the entire orchestra, making sure every part plays in harmony. Okay, so if the OS is a government, what exactly are its day-to-day responsibilities? What's it doing all the time?
Well, the OS really has two main jobs, and it all depends on your perspective. From your point of view, as the user, its goal is pretty simple. Make your life easy. Ease of use is everything. It gives you the nice graphical interface, the icons you click on, the menus, all the stuff that lets you get your work done without having to think about the incredibly complex hardware humming away underneath. But from the computer's perspective, the OS is a frantic, incredibly busy resource allocator. Its one and only job is to manage all the computer's resources, CPU time, memory, everything, and do it fairly and efficiently, juggling literally countless conflicting requests from all the different programs you have running.
You can even think of these resources as different government departments that the OS has to manage. It's in charge of deciding which program gets to use the CPU and for how long. It's allocating chunks of memory for each application. It's managing where all your files are stored on your hard drive. And it's controlling all your input and output devices, your keyboard, your mouse, your printer, you name it.
And this resource management, this constant juggling act, is the exact reason you can multitask. When you're listening to music while writing an email, it's the OS in the background expertly switching resources between Spotify and your mail app thousands of times a second. Without it, you'd be stuck doing only one thing at a time. Total nightmare, right? But this brings up a really important question. With so many programs running and all of them wanting a piece of the pie, how does this OS government maintain control? How does it stop one rogue app from causing total chaos and crashing everything?
So the heart of the problem is this. The system has to have a way to tell the difference between its own supercritical governmental code and the everyday code of your applications. It needs a way to protect itself and to protect other programs from either errors or, malicious behavior. And the solution is actually this fundamental rule of law that's built right into the computer's hardware. It's called dual mode operation. Here's how it works. Your applications, they all run in what's called user mode. Think of this as civilian access. They can do their own thing, but they absolutely cannot do anything that might mess up the whole system. The OS, on the other hand, gets to run in kernel mode. This is like having restricted top-level government access. In this mode, it can execute special, privileged instructions that user programs are forbidden to even touch. And a single tiny bit in the CPU, the mode bit, keeps track of which mode the computer is in at any given moment.
So how does an application ask the government for help without breaking the rules? Let's say your app needs to save a file. It can't do it by itself in user mode. Instead, it makes a special request called a system call. This call triggers something called a trap, which is just a signal that instantly switches the computer into the privileged kernel mode. Now the OS can step in, perform the task safely, and then it immediately switches the computer back to user mode before handing control back to your app. This entire round trip, this little dance between modes, happens thousands, sometimes millions of times a second. It's the absolute foundation of a stable and secure system. The separation of powers is what lets all your programs run together without stepping on each other's toes.
So let's bring it all home.
What's the final verdict on our OS government? Well, it's the essential bridge connecting your apps to the hardware. It masterfully manages and allocates all the system's resources, from CPU time to memory. It establishes that critical rule of law that protects the entire system from errors and bad actors. And really, when you get right down to it, without this invisible, tireless manager, the incredibly powerful computers we use every single day would be nothing more than really complicated, totally unusable boxes of metal and plastic.
And that kind of leaves us with one final thought to chew on. As our devices get smaller, more powerful, and way more interconnected, from our phones to our watches to the cloud, the job of the operating system is only getting more and more complex. So the question is, what will these computer governments of the future look like? And what new, wild challenges are they going to have to solve?